I was the engineering director responsible for Dremel for a number of years, and I actually left Google about the end of last year, so no longer with the company. But this is some of the work that we did way back when, and of course that project has continued, and I'll give you sort of a quick overview of how it started, what was unique about it, what happened afterwards, and so on. So let's see, how do I? Okay. Well, I should also tell you, I stole these slides from some of my previous colleagues, so they're not all mine, because I wanted to make sure that these were all slides that Google has used in some form in the past. But this was a slide that has this idea that a lot of people inside of the company didn't believe certain things that Dremel could do, and so this is a slide from my former colleague and good friend Matt Tolton. It said, you've got to try it and get a sense of what you do with the system. But in fact, you can be told a lot about what the system does, and there is a published paper in VLDB of 2010 where we describe a lot of the key characteristics of what the system does. So I'm the last guy on that list there. So basically, what Google as Dremel was about is just interactive query, right? So really fast query, no matter how big your data was. And so, what we were excited about at the time was trillion rows, right? That seemed big. And people didn't have trillion row tables around quite so much, and so we thought, okay, we should make it really easy to query trillion row tables. And in fact, so as it turns out, one of the early trillion row tables that we analyzed was on behalf of the cluster management team at Google that logged every single seek in drives inside of a Google data center. So as you can imagine, right, like every time a drive moves the head, right, it generates a little bit of information, and so you can easily get trillion row tables by doing that type of analysis, and then those guys would use the data for things like mean time to failure and reliability of disks and all this good stuff. And then ever since, right, of course, data grows, and there are many, many more examples. So Dremel, by the way, the name comes from this woodworking tool, which is meant to be like super flexible and just pull it out and do stuff with data. So that was kind of the general idea, right? You pull out Dremel and do whatever you need. And so Matt Tolton is the guy that I mentioned before that actually built a lot of these slides. So the system is widely used inside of Google at this point. It started out very much an engineering-oriented system. And in the early days, right, lots and lots of applications came out, very, very close to logs and this kind of stuff. So things like what Splunk does, for example, that was just mentioned. But then over the years, the system became a lot more capable and started to be used inside of other places, right? Spam analysis for ads, or OCR results for Google Books, or you name it, right? So, and in fact, the later years, I think, were also the most interesting because it went way out of engineering and became usable in finance and in sales and in billing and in all those kind of little more traditional areas inside of the company that themselves ended up needing to analyze big data in a lot of different kinds of scenarios. So this is roughly sort of just to give you a flavor of the types of examples. And again, a lot of it was motivated by making engineers more productive. Just like, hey, I don't want to write a MapReduce, right? I don't want to write Java. I don't want to write C++. I don't want to push my code into a cluster. I just want an answer, right? Can I walk up to a system that just makes that happen for me? And so that was one of our main motivations. And I think, in fact, one of the most useful ways that we used to do demos inside of the company was to say, give me 5 minutes. Let me show you something you don't know about your data in 5 minutes. And usually, if you could show somebody something interesting about their data in 5 minutes, they were pretty excited, right? So then the rest of the conversation went well. And so you could combine it with a lot of other things too. It wasn't sort of a use Dremel instead of. It was sort of, hey, look, you use a lot of stuff, and this is another piece in your tool in your toolkit. You can use it side by side to MapReduce. You can use it side by side to whatever you're using already to process your data. So that was a big element of the philosophy there. So in time, right, it started to be that when people had a big problem, right, it was like, where do I start? They could sort of whip out Dremel, do some quick queries, and then get a sense of, hey, what's big, what's small? In this spam category, who are the big spammers, who are the small spammers? In this fraud category, right? Is it happening, when are, roughly speaking, the dates when it happens? Like, where should I focus? And then maybe they did more analysis using Dremel, then they did more analysis using something else. It depended, right? So, but it started becoming a very sort of default way of getting started with your data. So with that, let me just jump in real quick to kind of what were the 3 basic ideas that started Dremel. And by the way, I should say, before I dive into the specific ideas, what I love about the Dremel project at Google is that it really started with one guy. There was one guy who's one of Google's principal engineers, brilliant guy. His name is Andre Gubarev, he's named in the paper. And he just felt like he had this problem of, why is it that it's taking me hours to analyze these logs? It's just, it really shouldn't take that long. And so he thought about it, and he had very interesting background from dealing with Google's data, and I think he came up with something that, in retrospect, boils down these 3 key ideas. So number 1 is a tree architecture. So a tree architecture means that when a query arrives into the system, it may arrive into a single server, and then that server passes the query on to maybe 10 servers, which then pass the query into maybe 10 servers each, on down. And then each of the servers at the bottom does a little bit of the processing, and they kind of pass the results back up the tree, right? And so every layer does a little bit of work. And so instead of a more classic MapReduce model where there's a master and a bunch of slaves, this tree actually allows you to do the processing a lot more efficiently for certain cases, right? So it's a fundamental idea. It wasn't new in Dremel. It's been used in search, and it's been used in other places. I think it's one of the first times when it was used in an OLAP-style system. I think another one of Andre's ideas in this, which, again, fundamental, at the time, everybody was super excited about putting things in memory, right? Because people had realized, like, oh my God, we can put the entire web in RAM. We can afford that now. So that was a really cool insight and very useful, and people are getting value out of putting stuff in RAM to this day. But I think what Andre realized is if you have a multi-thousand machine cluster and each of those machines has 10 or 20 drives, and you have tens of thousands of drives at your disposal, and each one of them reads 50 megabytes a second, you can get some pretty serious aggregate bandwidth out of that at a really low price compared to what you can get from RAM. And so you can actually go scan very, very large data sets very quickly and at a good price point. And so the tree architecture at the same time helps you to do all of that. Right? So that was one fundamental idea.
So
please, yeah.
But that's interesting because this is not just loading it in RAM. This is in disk I/O.
That's right. So
and I'm an old SCADA guy. I used to bring a lot of data into SCADA processors, millions of bytes of data. So that's interesting. And I always found data, disk I/O to be a lot smaller. So this is I did not know this.
It was a very counterintuitive thing inside of Google, right? And as you point out, a lot of people felt like disks, they're slow, right? What are you going to do with them? Well, it turns out, right, you can use disks in very interesting ways to get performance characteristics, provided you have the right distributed systems architecture on top of that. Now, which is not to say that we don't put things in RAM, right? And I think that that's also sort of where the system went in time, and not using flash and using RAM and using all these other good things. But again, I'm trying to focus on what was like really novel about what Andre sort of saw kind of all at once, and then created a project that in time became 80 software engineers and touched every part of the company, but really started from one guy. I think the other thing that Andre saw there was that you could really take a nested data model and write SQL in a fairly straightforward way against that. And what do I mean by that, right? So what I mean by that is a typical record inside of, let's say, a Google might say, here are all the searches that a user did on that day, and here are all the clicks that a user did on that day, right? And so you have one record that has a bunch of repeated queries and result clicks, right? But it's one record, and so you'd like to, write a query such as, for every user, tell me how many clicks they did that day. You don't want to do a bunch of joins, right? You just want to, express that inside that record. And so he, had this intuition that you could extend SQL a little bit and be able to express that very neatly. And also, he came up with a very, very compressed way of representing that data on disk. So what is called a columnar representation, but it was very hard to see because of the tree structure of the data. So that's kind of the nested data model, and I'll give some more details on each of these to kind of, I just want to give you kind of a priori the ideas, and then I'll dig in a little. And then the third bit was what we called in situ data access, which is basically like, we'll go get the data where it is. We won't import it into a system before you can use it. And so, in fact, early versions of Dremel did do that, right? They would import data into local disks and then query it. And then, actually, what happened was kind of a funny story, in my opinion. It was just, the SPPO infrastructure at Google said, there shall be no more storage systems at Google. You can't store data, right? You should really use the ones that we already have. But what do you mean? We're almost there, right? We're working on this. So don't care, right? Too many storage systems, figure it out. And so that constraint actually created the need to say, all right, well, let's think about it a different way. Could we go get the data off of GFS, off of Bigtable, off of these other places, and do away with all storage inside of our system? And so as it happened, that was a very fundamental thing. It was very hard, and it worked out. And it made Dremel a pure analysis system, not a database. So we call it a query engine in the sense that you take the traditional RDBMS, blow it up, and take just the pieces that you want, right? And say, okay, good, well, my data's on GFS, or it's in Bigtable, it's in MySQL, I'd like to query it over there. So those are the big ideas. Just to kind of give you a sense, right? So tree architecture means what I described before. The trees can be many thousands of servers. So imagine a Google data center with tens of thousands of servers where maybe we run on maybe even every node, right? So and that relies on a lot of really good stuff inside of Google. So very good networking.
And this is Jeff Dean?
So Dean, yeah, this is Jeff Dean, and we're talking about Jeff's paper in which he mentions the tree architecture, that was used in search. So that's the tree architecture. The records versus columns, right? So I think everybody has heard of columnar databases at this point. It's a fairly common idea of like, instead of storing the data in records, you store the data in columns. What's complex here is when you have tree data. So imagine JSON data, right? How do you put JSON data in columns? Okay, so that's a little more complex because maybe you don't know all the fields, or maybe some of the fields are under some other fields and so on. So there's some fundamental complexity in how that's done. And so that was definitely one of the big innovations I think that Andre saw all at once. And then finally, the SQL dialect for addressing that data. So what I'm trying to show here is an example of what we're talking about. So I was mentioning, a query result might have repeated names, and a name might have repeated languages, right? So there might be sort of JSON structure. And the language, so if you look at the select statement up there, it has some extra constructs such as within. Okay, so those are extensions that Dremel built to say, well, yeah, when you have this sort of slightly funny data, here's an extra keyword that you can use to address that. And so, it's both a strength and a weakness. It's a strength because you can say some stuff and it's quick and you can do what you want. It's a weakness because it's not standard SQL. And so a lot of tools such as a Tableau, ClickView, whatever, don't know about it. And so it's something that you can do inside an environment like a Google, and it works great, and maybe it's harder in an environment where you have less control over other elements. It was one of the reasons why the thing kind of had a lot of adoption, because people are like, okay, I can get this done, right? So, but definitely a very interesting extension. These are just some charts to give you a sense of, hey, on an 85 billion record table, how did we do against MapReduce at that time? All of that's changed since, but really the point was that Dremel was very, very fast. And it was very, very fast, not just because the system itself was very fast, but because the design was different, right? So the system was always on. It wasn't a MapReduce that you had to go around in a cluster and so on. So it benefited from how fast it starts and so on.
And that slide there, which you're showing is that if you go to record format, your 87 terabyte data shrinks to half a terabyte.
Correct.
When you go to column.
That's right. So if you store the data like this, right, in records, and you're running a MapReduce over that, you're going to read the whole record, but then you're only going to use a small part of it. And so if you read it columnar, you're going to read a lot less data, and of course your query is going to be much faster.
So is it, I'm just trying to understand, the execution time comes down drastically, and then the data usage is also, so what is the 87 terabytes versus 0.5? It's not the end storage, right? It's the data that's being used.
It's the data that's being read, right?
Okay.
So what's common is that a record is very wide, right? It might have a lot of columns. It might be, this is the user, these are all the queries that they ran, these are all the URLs they touched, this is what was spam and what wasn't, right? There may be many, many columns. And so if you read in a record-oriented manner, then you're going to read a lot of data, which you then very quickly discard, right? And so you'll spend a ton of processing time, doing stuff that you don't need to do, right? Whereas if you know that all you're doing is just aggregating information in the columns, and if you just can read the columns, which is important, right? It's like you have to have thought about the encoding previously to do it, then you can afford to read a lot less and therefore be much faster. So moving on, again, scalability. The point of the tree architecture was that it was designed in such a way that you could go to thousands and thousands of leaf servers and yet have the system work and actually decrease execution time of your queries. And that's a non-trivial thing, right? So going to thousands of servers is actually quite complex from a networking point of view, from a distributed systems management point of view. Selective assembly, I won't go into this in a lot of detail, but it's one of the technical things that has to do with exactly how you read the data. So for those who have some level of software development experience, like if you create a Java object, or if you create a higher level object, by then you've paid a lot of cost inside of your system. Whereas if you read the data raw, depending on your encoding, you can actually get 10x plus differences here. So this is actually one of the really important diagrams that's in the paper. It's a little bit technical. I'm happy to explain afterwards, but I just wanted to show you this picture. There are a lot of other features in the system. So in the paper we describe a certain subset, and then there are a lot of other things that got done over the years. So for example, joins were not in the paper. They got added. They were used extensively inside of Google, and little by little by little, BigQuery, the product side of Dremel, is starting to ship those features. So joins are now available. Part of joins are available now in BigQuery. And so on down for a lot of other things, such as running in multiple data centers, having quality of service, doing bulk updates, and so on. And so BigQuery is the product that I mentioned. It's sort of a REST API over Dremel inside of Google. So you can use this as a product today, right? It's a it's a paid product.
Yeah. I'm going to demo that.
You're going to demo that. Okay, excellent. Right. So you just basically walk up to a web page and just query it.
Yeah.
And so after all of that early story, there are a lot of later developments, and Google hasn't talked about those later developments, and so I can't talk about them either. But I can give you a sense, right? So some of those things are exploring the connections with other Google systems, such as tenzing. So tenzing is another system that Google published in, again, VLDB the following year. And it's much more like a Hive or a Pig. It sort of takes SQL, translates it into MapReduces. Very interesting system, does a huge amount of work inside of Google. So what are the relations between those query engines, and what can you do with that? Data visualization, so things like what Tableau, ClickView, and all of those folks did, how do they connect up with that story? Data warehousing, right? How do you build flows of data that go from group to group, from parts of the company to parts of the company that feed ad hoc analysis, all that good stuff. So we built on that. Like I mentioned, the group eventually became 80 software engineers, so as you can imagine, that's a lot of areas that you can explore, and some of the big ones were sort of the more traditional stuff that wasn't natural to start with inside of Google, because it's always easier to go with ads and search and groups that are always doing something sort of that is pushing the envelope of the systems, but where after it's matured a bit, you can then take it and put it back into the core business and actually really make serious gains inside of the company. So it's another one of Matt's posters, but we really did believe a version of this message, which is like, hey, one single query, okay, great, you can kind of mess around. 2 queries, you can start to get some information, but if you really start to get to know how to use the system, you can actually start to replace things and start to do things a lot faster. So that was ultimately what happened. Dremel is now in use by very, very large parts of the company. Pretty much every part of the company uses it at this point, and it's obviously also in the products that I mentioned, and it's also a back end for many other Google products that do analytics as part of the product, but don't expose Dremel specifically. Now that's also starting to change, where Google AdSense and Google Analytics are starting to expose their data in BigQuery so people can query it, right? So they can use that directly on Google's cloud. So with that, I'm going to break here. This was meant to be just a quick overview. So as I mentioned, I've left Google, and what I'm working on is a new big data analytics startup. It's called Metanautics. It's meant to help navigate the oceans of data that are out there. And would love to meet all of you and learn about your scenarios and talk more about the big data technologies that you're using. So thanks a lot.
One question. You said there's no storage. Are you using in-memory database, or is it every time it goes and queries?
So the question is, there's no storage, right? So do we use an in-memory database or do we do something else, right? So we do something else. We go read the data wherever it's resident. Every time, right? And so now we can also store versions of that data or store materialized views based on that, and query the materialized views or do other things. But yeah, the idea fundamentally is that the system shouldn't manage the data for you. It should give you that degree of freedom so that you can decide how you want to store it. That has implications on a lot of other things, right? So people, for example, talked about security, right? So security, if a system takes your data, then you have to kind of model that entire security model in that new system. Whereas if the security comes from the data store, well, then you can use your old model, right? It has to do with visualization, right? So if stuff is in this system, then can you use the visualizations that you wanted, or do you have to connect in a different way?
So is it more like federation?
So the question is it more like a federation engine? So yeah, in a lot of ways, it has elements of a federation or virtualization engine. So the difference is that it's actually also an execution engine, right? So a lot of virtualization systems, they just push the query into whoever's going to execute it, and then they just like stitch stuff up. Whereas the whole point of this tree is that it can do heavyweight computation, but it can also push things down. And so it sort of gives you an intermediate type of thing.
But you don't have any common caching or anything in the whole distribution process, right? There's no.
Yeah, so
you might
is there more caching? Yeah. So the caching story is really interesting. Happy to talk to you more about it offline.
Okay.
A lot of tricks went into how you cache, how you avoid caching yet get the performance, how you use the distributed file systems just right. So there's a lot of trickery there.
And the other thing that you mentioned is you're still using GFS, so you're not actually going after the HDFS. Do you have another file system layer on top of the traditional operating system file system, or Dremel has its own file system layer? Or?
So the question is, do you use HDFS? Does Dremel have its own file system? So Dremel doesn't have its own file system, right? It's not a storage system, it's a pure analysis system. Do we use HDFS? Google doesn't use HDFS. GFS was sort of the original HDFS, if you like, and then HDFS was based on that design. So Dremel used a lot of GFS inside of the company, but actually it used a lot of other storage systems. In fact, GFS I think is now deprecated or completely retired inside of Google. So the idea was that we'd use whatever data storage system the data was in, and now we had a file format, right? The columnar file format that I mentioned that you could put on any file system you want. So does that answer your question? All right. Was there a...
So Dremel is proprietary Google system, right?
Yes, that's right.
And when you say try it, what did you mean?
Well, so the question is, hey, it's a proprietary system. How do I use it?
Yes.
So it's a cloud service. So if you put your data on Google's cloud, then you can query it with Google's Dremel. Does that make sense? So Google has a storage system. If you're familiar with Amazon's S3, for example, or there are other storage solutions, Google offers something like that, where you can put a bunch of your data up there through whatever process you want, right? So upload it essentially.
Not
and
try as technology.
You can't try it in the sense that you can't download it and install it.
So it's not open source.
It's not an open source system, no, and it's not a downloadable product. And in fact, I think this is an area of opportunity for new startups that say, hey, it's great that Google and Amazon are going after the pure cloud market, but there's a big, big need inside of enterprises for stuff that they can install in-house and do this type of processing in-house. So super interested in talking to you about that.
Yeah. Well, the only way to try
So
it, just let them do this.
Last question.
Last question.
If say you're in the process and you have a bunch of Excel files, how would that translate into your columnar data store, since you're not going to actually be adjusting those there on the file system? How does that?
Yeah, that's a great question, and actually I meant to hit on the Excel point because someone else had brought it up earlier.
Yes.
So, I mean, I think what happened is for a long time we fought to get rid of the Excel files until we realized the Excel files are here to stay.
Yeah.
And so what Dremel will do is try to build connectors into a lot of different file formats. Now, as far as I recall, we didn't support Excel, but the idea of the system is that you could create a connector into a file in Excel format, and then express the connectivity between the table name and that Excel file, and then have the system go query it directly. So the ideal version of what Dremel would do if it supported Excel, which it doesn't, or it didn't then, would be to say, I'm just going to provide you a table name that maps to that file, and then I'll provide you the abstraction of just querying that file.
So every single Excel file would be a table within
Yes,
itself that
yes.
you would have to query them.
So the question is, would every single Excel file have to be a table? So it could be, and we did that for a lot of different kinds of files, but you could also create larger types of files that are groupings of Excel files or other files.
Assuming all the Excel files would have the same structure.
Not necessarily, actually, right? Like, so the question is like, hey, a lot of Excel files might have different structure. Can I treat them all as the same? So there were ways of saying, here's how you map that file format into this other schema that's shared by all of these other files, so that I can query them all as one thing. So, guys, I'm over my time, so I really appreciate the questions, and I'd be happy to chat more. So please feel free to hit me up after this. Thanks a lot.
Thank you.